Welcome to Solving a Variable with Wei Jun Chen. This is our equation. So, what is our goal? Our goal is to get rid of the parentheses. And how do we get rid of the parentheses? Well, we want to use distributive property, which is multiplying everything inside the parentheses by the number that is next to it, which is the number 3. So, this is our equation, and we want to multiply the number or everything inside by the number 3. And I kind of messed up my arrow. It's supposed to be pointing at the like 3 next to the parentheses, but it's whatever. So we want to do that. 3 times 3x is going to be 9x, and 3 times 32 is 96. So we want to bring everything down. And I was too lazy, and I didn't want to, put the equal signs in like a straight line. It's supposed to be a vertical line, and Mr. Benson did teach this, but I'm too lazy, and it's a Google slide. So, all right, now that we did that, what's our goal next? Our next goal is to combine like terms. And first, we need to know what is a term. So a term is just any number that is separated by like an equal sign, an addition sign, and a subtract sign, right? So every number, like let's say 96, or okay, the arrow is supposed to show that everything that's separated by the minus sign is a term, and an individual term is something like 96, 9x. So what we want to do is combine 96 with 100 because they're on the opposite side, or they're on the same side, and they aren't separated by an equal sign, so we can do combine like terms. But if they were different sides, you can't really do that because it's a math thing. So negative 96 plus 100 would be 4. And now we want to bring it down like what we did earlier. So what do we do next? What is our new goal? Our new goal is to get all the variables on one side, because if there are two variables, then that's not really going to work out, because we want to make our main goal is to get the thing to become something like, let's say, 4 equals x. That's your goal. So we want to get all the variables onto one side. Now, how do I get all the variables on one side? By isolating the term, or isolate the variable. It's the same thing. I gotta say both, or I'm gonna get beat up. So how we do that? We need to force a number to become zero, aka the variable. And how do we do that? We gotta do inverse operation, or zero pair for short. It's kind of the same thing, kind of not. I don't really know. It's like whatever. All right, so this is our equation. What we want to do is subtract negative 13. You can also subtract negative 9 from both sides, but I'm a little. I need to. You'll see. So negative 13, and there's a thing called the golden rule of algebra, which is whatever you do to one side, you do the other. So if it's separated by an equal sign like this, you wanna. So freak. If it was separated by an equal sign, you can't do combine like terms because they're separated, like I said earlier. So you want to do something called zero pairing, which is minusing one side to make the 13 become 0, and minusing the other, which is also called the golden rule algebra. I don't know. I don't really know the definitions like that. So, 9x minus 13x is negative 4x. So now our equation is negative 4x plus 4 equals negative 32. And next step, what's our new goal? I need to get rid of the constant. Now, how to get rid of the constant? I need to zero pair the 4 and also use the golden rule algebra that I just used earlier. Now, what is the constant? The constant is the number like 4 and negative 32. All right. Now, the reason we want to get rid of the 4 is because we want to make the equation something like negative 4x equals something. And the 4 is there. It's kind of in the way. So I'm going to get rid of that. And using the golden rule algebra, zero pairing with minus 4 and minus 4, And, we get negative 3x equals 30, negative 36. Now, the reason we can't do plus 32 and plus 32 is because if we did that, our equation would become negative 4x plus 36, which really wouldn't make any sense, and we're not really solving for the variable. So that's the reason we got a minus the 4x. Now, what's our goal? My goal is to simplify each side of the equation. Now, what is simplifying and how do I do it? Simplifying is trying to make the 4. Now we need to force a number to become 1, the 4, or the negative 4x, and get rid of the constant, which is the number right next to it. And the reason it says 17x is because I did a little mistake, so don't mind it. So what we want to do is divide by 4x, which would make it, first we got to know that the golden rule of algebra, whatever we do to one side, you got to do to the other. So when we divide negative 4x by 4, we also got to divide negative 36 by 4, and also we need to know that negative 1x is just x. So it would actually be negative 1x equals 9, or negative 9. And we can just turn that into negative x equals negative 9. I'm talking too much. Whatever. Alright. What is my next goal? My next goal is to make the x a positive. It doesn't really matter, I don't think, because I don't know. But we just want to make it a positive, because that's what Mr. Benson taught me. So, whatever. And to do this, we have to use inverse operation, which is, I guess it's like doing the opposite of what it is. So, let's say you have an additional sign, right? Or you have a positive, you make it into a negative. If you have a negative, you turn it into a positive. And so, we also got to do what we do to one side, we do the other. So, if we want to make x a positive, we also got to make 9 a positive. And let's say if 9 was just 9, and it was negative x equals 9. So that would actually be x equals negative 9. But our 9 was a negative too. So x equals 9. Now, what do? We gotta check. Oh, wait. I gotta teach you how to multiply by the reciprocal. Because Mr. Benson will beat me up and will give me a bad score on my presentation, which is not a really good thing. And the way you do this is basically, see this equation, right? 3/4 x equals 12. We don't really like the fraction. We want to turn x into a, what do you say? Oh, just x. We want to turn x just to x. Because, I don't know, it's just how things are. We don't like 3/4 x. It's yucky. And the way we do this is we kind of like flip the order of the denominator and the numerator. Now, that would mean we have to multiply to get rid of the 3/4. And when we do to one side, we do the other. So, 3/4 x times 4/3 is x. And we also want to do that to 12. Now, a way that Mr. Benson taught me to do this, which is pretty simple, is you want to multiply 12 by the top of the fraction and the bottom of the fraction, and then divide by the bottom of the fraction. So we want to do 12 times 4, which is 48, divided by 3, which would be 15. But I kind of messed up my slide, so it's not really a good thing. But it's whatever, People make mistakes, and I'm too lazy to redo this. I already procrastinated, and I didn't record for like a night. So, alright. So, oh shoot, that's not supposed to be there. Well, let's check our work. So, we know that x is now 9, so we want to replace the x with 9. And how do I check my work? Use distributive property for the 9 first. Then also use distributive property for 3. So, what I mean by that? Look at this. We want to multiply 3 inside the parentheses by 9, which would mean 3 parentheses, 27 minus 32, parentheses, plus 100 equals 117 minus 32. Okay, we also got a times 13 on the other side, which had an x by 9, which didn't really say. But it's whatever. Alright, what do we do now? Well, use distributive property, like what we did in the first time. And that would mean 81 minus 96 plus 100 equals 117 minus 32. Alright, let's continue to check our work. What do we do now? Do some simple math. I don't think I need to explain this. So, 81 minus 96, negative 15, plus 100 equals 117 minus 32, and then negative 15 plus 100, 85. Oh, shoot. That's supposed to be an equal signs. 85 equals 117 minus 32, which means 117 minus 32 equals 85. So 85 equals 85. It makes sense. Good job. You just did algebra. It's a flower. And I'm tired. I don't want to do this anymore. Mr. Benson, I don't want to do this anymore. Okay. Have a good night, Mr. Benson, if you're seeing this at night. Or good morning. Whatever. Have a nice day. And a good weekend.